Okay, so thank you so much for inviting me to talk about our technical report in this event. And it's titled, as you introduced beforehand, Chair Lady, it's Sustainable Transition to Industrialized Housing Construction in Developing Economies. And it was written by ETH Zurich University in Switzerland, where I'm also doing my PhD, and also a design and engineering consulting firm called ARB. And you can see some of the authors that participated in the report. So we mainly consider two main challenges that we want to address in this technical report. The first one was this global housing demand. I mean, we have seen that many already presenters talked about housing demand that's on the rise, and it's also predominantly felt in the African cities. On the other hand, we have this planetary boundaries that are set out to be the safe operating space for us, and we're managing to surpass those boundaries by the day. So the question we had was, how do we bridge this housing demand and also the planetary boundaries that we have to take into consideration? So you've seen it already on the title. We're talking about industrialized construction, and why are we talking about industrialized construction? The main reason is that the current construction industry has very low productivity rate. You can see it on this graph here. It's much lower than the total economy growth and also the manufacturing industry. So that's why we're not managing, in part, that we're not managing to supply enough housing to this growing housing demand. So some of the reasons are external forces, and some are firm level operational factors, the slow productivity rate, and I just mentioned two of them. So we know that construction projects are very complex, and our construction sites are also as complex. And we also see that there isn't enough digitization, innovation, and capital going towards this construction industry. Some solutions that have been proposed by certain companies or consultancy firms is that we should start thinking about, for example, rewiring the contractual framework between stakeholders in the construction industry. We should start infusing digital technology, new materials, and advanced automation. So all of these solutions together would give us about 50 to 60% boost in our productivity growth in the construction industry. And it also means that we have to employ more manufacturing-like system of mass production, industrialized construction in the industry. So that's why we're talking about industrialized construction as not just the whole solution, but as part of the solution of alleviating some of the housing demand that we see. So what is it actually? Industrialized construction itself, it's an umbrella term for prefabrication, pre-assembly, modular construction, and things like that. And in summary, it's moving away from this project mindset that we have in the conventional construction towards a more product-oriented platform. So there's already talk about industrialized construction and housing and sustainability, and I want to go a little bit through this research premise that we had in this research report. So we see an improvement in the construction safety. We see quality improvement with IC, or industrialized construction as we call it. It's weather independent. We also see higher predictability, shorter execution time. But what about environmental sustainability? Thankfully, there have been several research that are indicating to its also potential to provide environmental sustainable products. And this is a summary that's also available, research that's available online. You can check it out. We managed to summarize what are the environmental sustainability potentials of industrialized construction. So quickly going through it, in the value creation process of industrialized construction product, which is from the selection of materials until delivering to the user, the product's user, we see some benefits such as product optimization. There is a higher use of digital tools. We can start thinking about optimized designs in our products. We also see precision in manufacturing, where we manage to lower the construction waste that we see in the conventional construction. On the other hand, we have the value retention processes, such as the use and post-use phase, or end of life as mostly known. we have a potential, for example, to have this business model such as product as a service, where companies think about producing something that could be also returned back after its use. So having all of that in mind, the main question here is, how about the performance of industrialized construction in developing economies? We looked at three main cities in Africa. You can see Addis Ababa, Nairobi, and Cape Town on the list here. And we had two methodological approaches to evaluate whether the performance of IC in developing economies makes sense. The first methodological approach is life cycle impact assessment. We identified several products that we see in these three cities and did a life cycle impact assessment on the product and construction process stage and evaluated the global warming potential of these products. The second methodological approach was to look at the system in general in the context itself. And we had a formative scenario analysis as a methodological approach and identified key impact factors that are really relevant in the adoption of industrialized construction in the cities. So I'll start with the product scale assessment. So currently the conventional way of constructing housing is seen with this specific material that we also heard from Wolfram beforehand, that it's already predominantly applied in developing economies, which is concrete. Of course, cement is the most impact that we see in concrete, but I just start calling it concrete here so that we have the same understanding. So here we see concrete as the main construction material used. We also see that, we also see that the construction sites are also inefficient, which is also an indicator that the productivity rate is much lower because of this inefficient construction site. We see that there is enormous amount of waste created in this construction site. And there is also unmet quality demands, which is also not preferred in the eyes of the user, but also in our structures. We do not want unmet qualities. There are also some hope. Of course, we see there are some upcoming products and methodologies. I want to show three main products here. So one is the use of light gauge steel that we see in Addis Ababa. There is also expanded polystyrene applied in Nairobi. The third one is cross-laminated timber, CLT, in Cape Town. So we saw about, or identified about 20 products similar to those that I've already showed you, and we categorized them into three construction methods. And the first one is this conventional construction, where we categorized conventional materials such as concrete in this categorization, and the construction method in this conventional construction is mainly done by skilled labor force and not so much of prefabrication, pre-assembly, and things like that that I mentioned in industrialized construction. And on the other hand of the spectrum, we have fully industrialized construction, where we see innovative materials such as light gauge steel and the like, and low use of skilled labor on site. What is in between is partially industrialized construction, where we see a hybrid between the conventional and fully industrialized construction. So a quick show of some of the examples of the products that we have identified. The first one is conventional concrete masonry, which is mostly applied in Addis Ababa as a wall element. And we have in the second example, partially industrialized construction. We see the expanded polystyrene sandwich in between a shotcrete finishing element, and we see on the other hand fully industrialized construction with light gauge steel. So key, or what is a trend, is that prefabrication level of elements is increasing as we go from conventional to fully industrialized construction. And we also see that the in-country material sourcing is lowering as we go towards industrialized construction. So most of these new innovative materials that we see are not really manufactured in this case study cities, and mostly imported from countries such as Taiwan, for example. Coming to the environmental sustainability, so on the product stage, you can see that it takes the lion's share of the impact in total. So the type of material used and how much of that material used plays a big role. And we see that it's lower in the case of fully industrialized example, which is light gauge steel. And in this specific example, they used about 30% of their steel is recycled. So that could be a case. And we also see that they have some design optimization. They use lightweight materials and the like. And the fourth point here is the construction process impact. This is more related to what is the construction process on site. And as I mentioned before, fully industrialized construction only uses an assembly process and does not actually do much on the construction site, and most work is done off-site. A fourth example I wanted to show is something also very new in this cities, is the use of cross-laminated timber. And we see again that the product stage impact is much lower because of the use of timber. And we see the construction process stage also does not have a big impact in this specific example. Of course, these are coming from different cities, there are different examples, and we need to pay attention to the specific context that's applied to. So I just want to go through some key points from the analysis of the life cycle assessment. We know that the type of material used plays a big role, and we need to pay attention to what type of material is applied with industrialized construction. We need to think about primary material savings, such as design optimization, or also reducing construction waste. We see that transportation of materials and products also has an impact. Of course, not as comparable to the product stage impact, but we have to think about whether these materials are sourced from the country or are sourced from outside. The fourth point is that the factory processes, of course, with industrialized construction, we're introducing other processes such as factory processes, and we have to think about whether our energy sources are sustainable or not. As I mentioned before, the construction and assembly process also has a potential to be lowered with industrialized construction processes. As I mentioned before, we only did the the product and construction process stage impacts, and we didn't actually evaluate the use and end of life, but it's also an important point to point out. So moving towards the second methodological approach, which is the system scale. Here we, through interviews and through literature review and seeing examples from other countries that have already applied industrialized construction in their industries, we managed to identify 6 key category, that impact factor category, and 19 subcategorizations. So I want to go through some of them as an example. So here, the first one is product performance. So of course, we want to see that construction, the industrialized construction products are competitive, whether the quality meets the demand, time, design flexibility, material efficiency, and product cost, which is under the umbrella product performance. And we have the second impact category, which is state of industry. So here, as an example, we have manufacturing capability. So as I mentioned before, some of the materials are not actually manufactured in country, and this plays a role in companies trying to introduce new materials. So we have to think about whether these cities are ready to actually produce and manufacture some of the materials. The third impact factor category is state of city, and here we have trends of densification. We saw there is some correlation between high-rise buildings and application of industrialized construction, and in most instances we see industrialized construction performs better when constructing high-rise buildings. The fourth category here is state of market and economy, and I have an example here, unemployment rate, for example. which is under state of market and economy. So in some of the cities, or most of the cities that we have analyzed, we see that the unemployment rate is higher, and people have not so good impression of industrializing the construction industry itself, because they think that it could be linked with lowering or increasing perhaps the unemployment rate, or remaining the same. So we have to think about whether we want to have jobs that also could be created with industrialized construction in the specific cities. The fifth one is policies and regulation. Here, as an example, we have availability of building codes for industrialized construction. So most of the building codes that we see in the cities is more prescriptive, and it's not a performance-based building code. And we need to check whether we actually are matching this move towards industrialization, and whether our building codes are also coming along. The last one is society, and we have perception of IC by the end consumer. Of course, at the end, the user gets to decide whether they would like to purchase that specific product. So we have to think about whether that product meets the standards of the consumer. So after doing some systems analysis of these 19 impact factors, we plotted them on a system graph, and you see here there are 4 categories: active, buffering, passive, and ambivalent, and these are the roles in their system. So as an example, we see here condition of infrastructure in the specific cities as an active factor. So condition of infrastructure involves the availability of water, the availability of electricity, and quality rules and things like that. So when companies think of creating an industrialized construction product manufacturing facility, this is something that they really consider. So we have to look at our condition of infrastructure in African cities. On the other hand, we see incentives from government for industrialized construction having an active and a passive role, which is under ambivalent. And we need to think about perhaps boosting some of these companies that are trying to introduce innovative materials and methods in the specific cities. So finally, we tried to show some 4 ways industrialized construction adoption could take place. The first one is business as usual, whether this is showing if we leave the construction industry as it is, and no intervention from the government, no intervention from private companies, we would have still large unmet housing demand going forward. And perhaps what we have is a high design flexibility. The user gets to decide how they would design their building and which material they use and the like. The second level is this lukewarm industrialized construction adoption. So perhaps applying some innovative materials in some parts of the building. Here you see the roof having an industrialized construction product. On this scale, we have medium unmet housing demand, as we're not doing the whole housing with industrialized construction methods. What we have as a positive here is perhaps we promote skilled craft labor, and we don't completely change the construction processes. The third level is the cozy adoption of industrialized construction. Here we go forward with incentivizing the innovative construction methods, and we give incentive for creative solutions, software tools, offsite facilities, and the like. And perhaps we end up with low unmet housing demands, and we also promote not just skilled laborers, but skilled knowledge workers, and perhaps we also have higher design flexibility. The last level is this burning adoption of industrialized construction. So without really giving context to the application, we might end up with just one benefit of industrialized construction, which is mass production, and we would not be involving the user as much, and perhaps we will be having low unmet housing demand, but the perception of the consumer might not be positive at the end, and low design flexibility is also a negative factor. So at the end, our framework was to think about the context of the cities, think about what are the product aims we want to have, think about the levers that we have to change the industry, and think about the actions that we could do to move with these levers. And as a summary, I have here a note to say that this report is try to show this intricate ecosystem of adopting industrialized construction in a sustainable way in developing economies, and hopefully it's kind of a report that makes the decision processes of stakeholders easier. Thank you very much, and open for discussion.
Thank you so much, Kedir, for the insightful presentation. We have a couple of questions. I'll just read from here. Yeah, the first one says, what about the environmental impact of the adhesives required for cross-laminated timber? They are usually ignored in the environmental assessment for being negligible. And also the availability of the laminated timber, the adhesive in Africa. Do you want to take that, or you take the two questions together?
Sorry, I'm trying to find out where it's written because I didn't hear it. Maybe you could repeat it. Sorry.
Okay. The first one says, just a minute. What about
adhesive?
Environmental? Okay, yeah.
Yeah, I mean, a fair point. For sure, it's this is the side of cross-laminated timber, and the negative side of introducing CLT in the market. But as you can see in our specific evaluation, it didn't play as big of a role as compared to the other alternatives. So of course we have to think about it, but as it is in our assessment, it's not really showing to an extent that it's worse than conventional construction products.
Okay. The second one, was the embodied carbon estimated to see its impact on positively or otherwise on the environment?
Okay, I'm not completely sure if I understood the question, but the evaluation of the embodied carbon for some of the products it's positive, for some it's not, right? So it depends on the specific product we're talking about. I don't know if I understood the question well.
Oh, okay, or maybe you could engage with the person later.
Yeah.
On the chat. Yeah, and there's this one, let's just pick this one. What is the timeline of the next steps, such as tools and wiki, etc.? What is the timeline of the next steps, such as tools and other instructional materials? Can you see the
timeline for me for my next project, or
maybe you would chat up with the person to get more, because
timeline.
Yeah, maybe you would engage with the person later if it's not clear.
Yeah, would be happy to do so.
Oh, thank you. I think there are no further questions. Thanks so much for your paper.
Yeah.
Thanks so much. Thank you.
Thanks.
So we'll just quickly